In this video, we'll talk about models and applications, so in other words, word problems. I know that's everybody's favorite topic, but it'll be okay, we'll get through them. All right, so in this intro example, it says a new car worth $35,000 is depreciating in value by $3,000 per year. Ooh, let me turn my pen on. That would help. There we go. All right, so $3,000 per year. $35,000 is the fixed starting cost. $3,000 is a fixed cost. So we can think of X as the number of years that we own this car, right? So going forward, you'll see me kind of translate into this X notation. So part A just says, what will be the car's value in 1 year? So of course you can just take 35,000, subtract depreciation from 1 year, and that gives you 32,000, right? Easy peasy. We include our units. What will be the car's value in 2 years? 35,000 minus 2 times 3,000 would be 6,000. Gives us $29,000. Okay, so nothing too crazy so far, right? And we could keep this pattern going, right? So it says determine after how many years the car's value will be $23,000. So we know after 1 year it's 32,000. After 2 years it's 29,000. After 3 years, right? After 3 years, we'll subtract another 3,000 to get 26,000. So we're not quite there yet. And then after 4 years, we'll subtract another 3,000 to get to 23,000. So that means after 4 years, right? All right, so when we're doing this, we're all just kind of doing this step by step. We're not really using any algebra. We're just kind of typing numbers into a calculator. So now for part C, it says write a formula that models the car's value Y in dollars after X years. So X is going to be our number of years like we mentioned before. And notice that up above, where in part A I have 35,000 minus 3,000, I could rewrite that as 35,000 minus 3,000 times 1, right? That's equivalent. Over here, I could write 35,000 minus 3,000 times 2. That's the same thing as minus 6,000, right? So following this pattern, for my value Y, I start with my initial value of 35,000, and then I'm going to subtract $3,000 for every year that passes. 3,000 times X. In part A, after 1 year, X would equal 1. After 2 years, X would equal 2. After 3 years, 35,000 minus 3,000 times 3 would give us that 26,000 results. You can see how that would be the model. And for part D, use this formula to determine after how many years. So again, we're solving for X, right? What's X? The car's value will be $14,000. So they give us $14,000, the car's value. That's going to be Y because Y is the car's value. So I'm going to set up my equation as 14,000, my car's value, equals 35,000 minus 3,000 times X. And then to solve this, I'll subtract 35,000 from both sides because I'm trying to solve for X. So negative 21,000 equals negative 3,000X. And then when I divide both sides by negative 3,000 by negative 3,000, a negative divided by a negative gives me a positive. So X equals 7 years that have passed. Okay, so this is a pretty basic example. Hopefully it wasn't too challenging for you guys. And we didn't openly discuss it, but we basically used some of these 5 steps when we were trying to set up that model. So first, we want to let X represent one of our quantities. Then we can represent other quantities in terms of X, so like the car's value in terms of X. write an equation in X that models the conditions. So that was our Y equals equation. Solve the equation and check the solution in the original wording of the problem. All right, so for number 1, it says when 70% of a number is added to the number, the result is 1054. What is the number? So we keep talking about the number, the number, the number. So let's set that guy equal to X. That's our unknown quantity, right? And there aren't any other quantities we want to set up in terms of X quite yet. But let's go ahead and try to write an equation that models the conditions. So I'm going to be really literal in translating here. So it says when 70%, I'm going to translate that into the decimal 0.70. So we can always convert a percent to a decimal by moving the decimal place 2 times. 70% of means multiply in math. So 70% of a number X is added to, so I'm going to put a plus sign here, is added to the number. Remember that we're calling the number X, so I'm going to write X there. The result is, that means it equals 1054. All right, and simplifying, if I add 0.70x to x, remember there's a coefficient of 1 there. This gives me 1.70x, oops, didn't mean to zoom in there, equals 1054. And then we can divide both sides by 1.70. So 1054 divided by 1.70 gives us 620. And I don't need to use units because here we're just talking about general numbers, right? There's not, dollar signs or any sort of, specific unit that we have to deal with. But for all of these, do remember to include your units wherever appropriate. All right, so for number 2 is kind of deceptively tricky. So it says including 6.5% sales tax, the Hotel California charges $202.35 per night. Find the hotel's nightly cost before the tax is added. All right, so a lot of you guys, what I'm about to do over here is wrong. But what a lot of you guys are about to do is say, oh, 202.35 minus 6.5%, 0.065 times that price, 202.35, boom, 189.20 if I'm rounding to the nearest cent. What's so difficult about that? The bad news is that's actually the wrong answer. So if you work this one out and get 189.20, I appreciate the effort, but unfortunately it's incorrect. The reason is the 202.35 already has the tax in it, right? So it says including the sales tax, they charge 202.35. So you can't apply the 6.5% tax again to that total amount that already has the tax in it. So instead, we know that in general, for kind of any tax setup, you have your original sticker price plus the tax amount, and that equals the total, right? So we're looking for the original cost before tax, right? So we can call that original cost X. That's our unknown, right? So what's the cost before tax was added? Then we'll add some tax amount, and we'll get to that in just a minute because that's kind of the tricky part of this problem. And we know that our total price is $202.35, including the tax. So we need to figure out how to represent this tax amount, right? So we know that the tax rate is 6.5%, or as a decimal, 0.065. And if I apply 6.5% to that original price, that gives me the amount of tax that I pay on top of the original. So I'm going to take that tax rate, 0.065, but I need to multiply it by X. I need to multiply it by that original price, and that gives me the tax that I'm paying. So this is the equation I set up. And remember, there's a coefficient of 1 there. So combining like terms, 1.065x equals 202.35, and then dividing by 1.065 on both sides. Gives me 190. And remember, our units are in dollars. So the hotel costs $190 per night before taxes. All right, let's take a look at number 3. A carpenter is building custom cabinets. The materials cost $2,500, and the carpenter charges $80 per hour for labor. If the total bill is $3,020, how many hours did the carpenter work? So again, we like to set up our unknown values. Let's let x equal the number of hours, since that's what we're trying to figure out. All right, so we've got this fixed materials cost of $2,500. So if I'm trying to represent the cost, I know that there's that flat cost of $2,500. That doesn't change. Plus the carpenter charges $80 per hour for work. So plus 80 times x. If the carpenter works for 1 hour, the charge is $80 extra. If the carpenter works for 2 hours, the charge would be $160 extra, and so on. And we know that the total bill was $3,020. All right, so now we can solve for x to figure out how many hours the carpenter worked that week. So we can subtract 2,500 from both sides. So 3020 minus 2,500 gives me 520. So 80x equals 520. And then divide both sides by 80. So x equals 6.5 hours, or 6.5 hours.